थोड़ा सा बहन का लौड़ा आ गया। अबे तू थोड़ा सा बहन का लौड़ा। मैंने तो कोई हीरा छोड़ के कचरे के पास क्या कमी की। मैंने तो कोई हीरा
Hello, Saurabh.
Hello, sir.
I don't know the other person is going to join or not. I think Raghavendra was there, right?
Yes, sir.
He came in the last class of motor, maybe, but not now. We'll just see for 1 or 2 minutes more. If he's not coming, then we'll start.
Okay.
How the preparation is going on? Good.
Yes, sir, good. सर
Yeah,
इलेक्ट्रिकल का तो ठीक है क्योंकि अभी नेवल का मैंने हटा दिया तो इलेक्ट्रिकल पे मैं ज्यादा कंसंट्रेट कर सकता हूँ और
naval
नेवल
also you do at least 10 questions. You don't know
नहीं
the
सर।
luck.
सर नेक्स्ट मंथ दे रहा हूँ नेवल का। दोनों न्यूमेरिकल वाले एक साथ नहीं दूंगा सर। वो भी दोनों एक ही
तो,
डे पे पढ़ते हैं। 22 को है एग्जाम तो दोनों
वो तो है।
मॉर्निंग। हाँ, मॉर्निंग में ये है, शाम को वो है। एक एक दिन का गैप भी होता ना तो थोड़ा ठीक रहता है। अगर 21 22 होता है तो वो सुबह शाम में थोड़ा बता दो। तो
हम्म।
मैं मोटर मोटर और ये सब ज्यादा दे रहा हूँ और नेवल और वो नेक्स्ट मंथ।
ओके। Yeah, I think we should start. He will not come. Okay, yesterday we started the starter and we discussed about star delta, DOL, all those starter. This is going to be your first attempt, right?
हाँ, फर्स्ट अटेम्प्ट।
What about theory part? You are doing the theory part also, right?
या थ्योरी पार्ट एंड सब पार्ट।
Your numerical, we are covering most of them together, but theory also you take side by side. Just see the questions. In theory, they are not going anything out of the box. Same question is getting repeated, right? And if you can't find an answer to any question, this you can post. I will answer. Okay.
ओके।
I also started the theory part, obviously. But it has to be perfect combination of theory as well as numerical. Okay. In the last class, we started the starter and we discussed about star, delta, DOL. This type of starter we already covered. Today, I'm going to show you the slide which starter you are going to draw actually. Just a moment. I think you can see my screen or no?
नो।
Now,
स्टिल नॉट। हाँ, नाउ
I hope now you can see.
इज।
So this is the actual circuit you are going to draw for DOL starter. Okay, this is the circuit you are going to draw for DOL starter. We already discussed everything.
यस सर।
Stop and reset. This is the start button. This is start for the remote. This is start for the local. And additional only there is one lamp, right? And yesterday you were asking how they will be connected. Transformer you will show like this. Okay. And star delta you first draw that star and delta picture and then draw this circuit. This one. Yesterday we finished with the star delta, right?
Yes, sir.
And some time delay and all is remaining. So this is how the time delay is connected. This KM2 relay is only acting as a time delay. KM2 as a pair of
सर कौन सा टाइम डिले बता रहे हो आप सर? टाइमर स्विच?
स्टार और डेल्टा के बीच में कुछ टाइम डिले होना चाहिए ना, दोनों एक साथ.
हाँ, एक साथ स्विच नहीं होना चाहिए, तो
हाँ.
शॉर्ट सर्किट होगा.
So there is a time delay. So KM2 latch is acting as a time delay. KM2 as a pair of auxiliary contact. So there are pair of auxiliary contact. This is one. This is the other one, right? Two. So that's why they are saying pair of. With a time delay action, typically 40 milliseconds between the opening of normally close and closing of normally open contact.
Yeah.
So when you look at the power circuit, when we talk when we talk about the power circuit, in the power circuit, this part is known as the power circuit and this part is known as control circuit. So just see what happened in the power circuit. We have the fuse isolator Q1, closing of KM1. What type of connection?
सर दिस इज
Star, right?
स्टार कनेक्शन के लिए सर एनालाइज
KM1 and KM2 and your motor will start.
KM2
Opening of KM1 star connection open and closing of KM2 KM3 delta connection close. KM2 and KM3 contactor drops out when then your motor will stop, because in the end motor is running in the delta, right? So KM3 and KM2 has to open for stopping the motor. For that they have put the OCR here also. You can see F1 is OCR as well as stop switch. So what happened in the control circuit? You are going to reduce the voltage first. You have
220 volt
example, we are reducing to 110 volt from the control transformer. This is your control transformer. Press the start switch to S2 if you are going to press the start this one. To close the KM1, your circuit will get completed from here and KM1 will energize and this KM1 will close and this KM1 will close. Understood this one, this much?
Yes, sir.
When your KM1 this close, KM2 also close, right? Because the circuit will also get completed and this KM2 will close and this KM2 will close. Holding of the KM1 and KM2 by KM2 auxiliary. So KM1 and KM2 is holded by the auxiliary contact of the KM2 because KM2 is energized. So this one is energized. And since this one is energized, so this one is also energized, right?
Yes, sir.
Opening of KM1 by KM2. So KM1 opens, the contact of the KM1 open by KM2. How by KM2? Because there is a time delay. As soon as the KM2 is going to get energized, this will open after the 40 milliseconds. Closing of KM3 by KM1. KM3 is getting close by the KM1 because this is going to open and this is going to close, right?
Yes, sir.
And stopping you can done by the disconnecting using the S1. Understood?
Yes, sir.
So this is the circuit we are going to show for star delta. So next one is auto transformer.
सर टाइमर अभी भी उसी में ही इंक्लूड कर लेंगे जो आपका KM2 और
इसी में ही
KM3 का?
टाइमर, इसी में ही टाइमर इंक्लूड है।
ठीक है क्योंकि नहीं मैं जैसे क्लास 4 में पढ़ता था ना सर, वो टाइमर का एक अलग सा वो बना के रखा था
नहीं, ये टाइमर भी है as well as interlock भी है. Can you see?
हाँ
When
वो मैं समझ गया.
your KM1, the auxiliary contact of KM2 is only going to make on the KM3 line when it will open from here, so that both of them are not
हाँ
close
वही.
together. Okay. So next is auto transformer. So this is the circuit for the auto transformer. These are your, let me make it big first. This zoom controls are not working. I don't know why. Sometimes it gives trouble.
और सर वो थोड़ा माइक्रोसॉफ्ट वाला कौन सा होता है, वो थोड़ा ज्यादा बेटर रहता है. कभी कभी ऑडियो ऑडियो का भी बहुत लंबा हो जाता है.
I'm not getting the control option only now.
सर ठीक है, मुझे
Okay,
विजिबल है.
okay.
नो नो प्रॉब्लम.
Okay, now it's okay. So these are the three-phase supply coming from the top, right? Coming from the top, going into the KM2. Then there is auto transformer winding, and you can take tapping from the winding, and there is one KM3 contact, and from here it is finally going into the motor, and these are the KM1 contacts. We'll just see what they are saying. Technically, this is the best way to optimize the startup of a induction motor. So this is the best method. The best resolve a conflict involved in reduced voltage starting. The conflict is between reducing the starting surge current while starting and causing the run-up time to be excessive. The transformer provide a number of secondary tapping, typically 50%, 65%, 80%. The starter can be wired from to the appropriate tapping. So you can take the wire for your starter from any position in the winding, right? A major advantage of this type of starter over the star delta type is that a simple cordon for connection and sequence allow the motor to run without run up to the speed without disconnecting. So in the star delta there was a disconnection time, right, when it is switching from star to delta, but here there is no
डिस्कनेक्शन डायरेक्टली सर कोई
disconnection time. This
टाइमर नहीं
avoid,
है.
yes, this avoid the opening transition surge problem. We already seen this one. Opening started open transition surge current
हाँ सर.
because the current is still flowing in the rotor and it produces the current in the stator. And if your wires are not correctly connected,
wires are not connected, it will lose insulation.
EMF will be different than the what EMF you are putting there. Okay. Generally, this starter tends to be used for the large drive above 60 kilowatt motor. Normally, they are on the above 60.
60 किलोवाट. सर इसका एक बार जरा सर लाइन जरा दिखा दीजिए, किधर से क्या आ रहा है, मतलब कि किधर से वो थोड़ी सी कंफ्यूजिंग हो रही है. किधर से वोल्टेज किधर से आ रहा है, ऊपर से लाइन से आया जो मेन डायग्राम था इसका. ये सर थ्री फेज सप्लाई आई, तो सर ये पहले किस में जा रही है, ये पहले इधर वाले स्टार में जाएगी ना.
पहले KM2 में जाएगी अगर जब ये ब्रेकर बंद. अब जस्ट होल्ड फॉर ए मोमेंट.
ओके.
जैसे जैसे हम बढ़ते जाएंगे ना आपका क्लियर होता जाएगा. That's
सर
why I'm not showing that full circuit directly, right? This is the full circuit. So this one is, yeah, this is the full circuit. So I'm building the concept slowly. Okay, just give me some time. Generally, this starter tend to be used for the large drive over 60 kilowatt but may be seen in smaller drive also, where star connected motor have been adopted for the ease of protection. Delta, so if you are using any star connected motor, then you will see this one. Delta connected motor are more difficult when it comes completely protecting against them the single phasing condition than star connected motor. Operating principle. The operating principle of this starter is that step down transformer is used to provide the reduced voltage. So we are stepping down the voltage. So this is the final UVW is going to the motor starter. The motor is allowed to accelerate and then the wall voltage is applied. So first, what will happen? This phase is coming from here. This circuit will complete from here.
KM2.
And you are taking tapping from here and you are reducing the voltage. So obviously the voltage will go from here. So now suppose your motor is already started and now you shifted the transformer slowly to the same voltage. Once it is on the same voltage, you can close, if you close the KM3 also, so you can apply the same voltage which is coming from top, right? And your auto transformer is isolated, right? Understood the circuit now? The motor is allowed to accelerate and then wall voltage is applied. First, you will accelerate the motor using these voltage, which you are tapping from your auto transformer. Then you are going to apply the wall voltage. Then you are going to close the KM3 and you are going to apply the full voltage, right? The transformer will require protection against over temperature. So for this transformer, we are required the protection against over temperature. So you must have seen some engine room blowers. Some engine room blowers are supplied from the auto transformer and it is written on the panel only. Do not start consecutively for 3 times. Right? Or sometime it written after every attempt, wait for 15 minutes, right? Because they need some time for cooling if you are starting frequently. Since the motor override relay is not designed for this function, motor override relay is something else, and this is in the starter. Auto transformer starter is in a corridor of connection. When the start button is pressed, contactor KM1, this is KM1, okay, and KM2 close together. So KM1 and KM2 will close together, and this will apply reduced voltage to the motor by the auto transformer. This much is clear? Okay, next. After a preset time delay, which allow the motor to run up, contactor KM2 opens. KM1 opens. This end the auto transformer action and motor is connected to the main supply through the throw part of the transformer winding, which merely act as a choked cell. So now KM3 will close and the wall voltage is applied to the motor. KM2 open and disconnect the transformer from the supply. So KM2 will open, when KM3 will close, KM2 will open and it will disconnect the motor from the supply. So the sequence is KM1 and KM2 closes. There is some time delay, then KM1 opens and KM3 close, then KM2 open. So that your auto transformer is completely isolated from the system. The motor is never disconnected from the driving voltage and this prevents the current surge. So at any point of time, the motor is not disconnected from the voltage. So when KM1 opens, still the KM2 is supplying the voltage to the motor, right? Then KM3 close.
सर इसमें शॉर्ट सर्किटिंग का चांस नहीं होता जैसे उसमें होता?
शॉर्ट सर्किटिंग का चांस कब था? जब हम लोग
डायरेक्ट ले लेते हैं।
स्टार
हम्म,
ओपन कर रहे थे और डेल्टा क्लोज कर रहे थे, राइट?
हाँ
इसमें वो ओपन कर ही नहीं रहे हैं ना, लिखा है ओपन हो रहा है, बट
हाँ
एक्चुअली दिस इज वेरी फास्ट. KM1 open, KM1 and KM2 is closed, and there is some time delay. KM1 open and closes a KM3. So your voltage will start going from here. And then finally you are isolating your transformer.
ठीक है।
This is the circuits looks like. Just see if you can understand. This is the, don't draw this one. This is the start button, right?
Yes sir.
This is the start button. When you are going to press this one, what coil is getting energized?
KM1
KM1 is getting
energize. KM1 is
energized. This
KM.
controls is giving a lot of problem today. So KM1 energize. So when KM1 energize, what happens?
KM2 energizes. This closes sir ये 1 2 3 वाला जो ऊपर वाला वो
KM1
closes.
KM1 will close.
हाँ
KM1, do you remember in the last circuit? This one, right?
yes sir. हाँ सर.
Okay. Then when this is closed, this KM1 will also close, and this
Yes
is
sir.
going to close the
KM2.
KM3,
अच्छा हाँ
KM3, right? And it is also going to, some latches
सर
name are
सर
not
सर
written here.
हाँ सर नहीं सर ये देखिए ना KM1 से आपका डायरेक्टली KM3 पे चला गया. KM1 से तो KM2 पे जाना चाहिए था ना. KM2 एनर्जाइज होगा फिर आप जो F2 है जिसको स्विच को है तो वो रिटेनिंग कांटेक्ट बनेगा. फिर रिटेनिंग कांटेक्ट के बाद हम लोग KM3 छोड़ेंगे ना तुरंत.
KM1 से क्या बनना चाहिए? KM2 बनना चाहिए ना.
हाँ
सो KM1 इधर से बन गया, KM1 इधर से बन गया, तो KM2 actually some names
KM3
are missing here ना.
हाँ
That is
KM3
the problem.
ओपन. KM3 ओपन होना चाहिए.
हाँ, KM3 तो ओपन ही है, ये क्लोज हो जाएगा. ये KM1 का रिटेनिंग कॉन्टेक्ट होगा, ये क्लोज हो जाएगा. जब
हाँ
KM1 बन गया, एक ये KM1 क्लोज होगा, एक ये KM1 क्लोज होगा. So it will come from here to KM2. So
हाँ
this KM2 will close from here.
हाँ
So power circuit will complete from here.
हाँ सर.
I'll just tell you the theory part. Just wait a moment. I have one more diagram. This diagram is not so good. Let's see with the other diagram. This is the diagram you are going to draw. Now this is the complete diagram, right?
हम्म,
So when you are going to press the start switch
S2
S2,
हाँ हाँ
this will going to energize the
KM1
KM1. So this KM1 will close. This KM1 will
close.
open. This is
हाँ this is normally closed. This will open.
this will open. This
हाँ
KM1 will
close.
close.
हाँ
This KM1 will close.
हम्म,
KM3. No. Here the symbols are. Oh yes, KM2 should close. No.
KM2
So
भी close
yeah,
होगा सर रिटर्न का.
KM2. But KM2, this will close.
K
KA1.
KA1 भी close होगा सर
Okay,
KM1 के साथ
we'll
साथ.
go by this. So power circuit operation,
हाँ
manual closing of isolator fuse Q1. This is a manual closer.
जी सर.
Closing KM1, star connection of the transformer. This is the star connection of the transformer. Closing of KM2, motor supply via the transformer. When KM2 is closed, is right.
हाँ
These are the tapping and motor is getting supplied. Opening of KM1, star connection open, star connection opens.
yes sir.
Of closing of KM3, direct supply to the motor.
हाँ
This is in the power circuit. Note mechanical interlock between KM1 and KM3 contactor drops out to motor the to stop the motor. Now we'll see the control circuit. This is the control circuit. You are reducing the voltage to 110. You are pressing the start switch S2 to close KM1. So when you are pressing S2, your KM1 is getting energized and your KM1 is getting close. Interlock of KM3 by KM1. So KM3 is having the interlock with the KM1. Closing of KA1 by KM1. So KA1. Where is KA1? This is KA1. This is get closed when your KM1 is energized. Okay. Closing of KM2 by KA1. KA1. Closing of KM2. So this KA. So now when this is getting closed, this circuit is getting completed, right? So when this KA1 is getting energized, this KM2 is getting close. Okay. Holding in of KM2. So this KM2 is coming into the picture. Now this KM2 is getting energized and this KM2 will get close. Opening of KM1 by KA1 after time delay. So this KA1 will get open by KM1. And there will be a time delay. Sorry, KM1 open by K1. This KM1 opens because this time delay, this is going to
open and
move,
KM3 will be closed.
KM1 will be out of the picture. So closing of KM3 by KM1. So when this will open, this will close, KM1 will close, and circuit for KM3 will close. Now you are going to hold the KM3. Opening of KM2 by KA1. So your KA1 is doing the opening of KM2. As soon as this is going to close, this is going to open. This circuit is little bit complex. Try to remember. And you are reducing the voltage. Obviously, you know the principle of transformer. Same we are applying here.
Yes, sir. Lowering the voltage for by
N1 upon N2, V1 upon V2, right?
Yes, sir. Winding.
You are taking from the same this thing, same winding only here. That is the only difference. I hope you are comfortable with this one. You need to just check this one again 1 or 2 times more, then you will be okay. Okay, now we will move to the question which you sent in the group few days back. So what was your question? First question?
PN junction diode.
A 500 volt, right? I'll just put the question first.
हाँ ठीक है 500 वोल्ट सिंगल फेज मिल गया सिंगल फेज हाँ
I'm pasting this a moment. So just read the question. What all things are given? A 500
volt one phase synchronous motor gives a net output mechanical power of 7.46 kilowatt and operates at 0.9 power factor lagging. Its effective resistance is 0.8 ohm if the iron and friction losses are 500 watt and excitation losses is 800 watt. Estimate the armature current. Calculate the commercial efficiency.
Okay. So what is motor input power or motor power? Any power? VI cos phi. We know all this.
Yes.
Power is VI cos phi. Right? VI cos phi. And what is copper loss?
I square.
I,
I square.
I square R, right? I square R. I square R. So what will be the power developed by the armature? If this is the input power, this is the losses. So power developed will be input power minus losses, right? So what will be the power developed by the armature? Power developed will be equal to VI cos phi minus I square R. Okay. What is the power output given in the problem?
Power output is 7.46 kilowatt, like 7,460 kilowatt. Watt.
Power is 7460 watt. So what will be the total power? Total power will be output, that is 7460, plus iron and friction losses. What are iron and friction losses?
Sir, iron losses is
500, right?
500
Plus excitation losses, that is 800. What will be total power?
Uh, 8760.
8760. So we already discussed few things before. What we discussed before?
Sir, power.
We got equation like what? PM.
Sir, power
power.
total power is equal to input power minus
VI cos phi minus I square R.
I square R.
So can you calculate the value of I from here? You know the power now. You know the value of V. You know the value of I. You know the value of. You don't know the value of I.
Yeah, I की value.
You know the value of cos phi. You know the value of R.
R की value.
So you can calculate the power, right? Only one thing we don't know, that is I. So we can calculate the I. And what they are asking next, I think this is the one of the part, right? Calculate the efficiency. They are saying calculate the commercial efficiency. So what is motor input? VI cos phi, right? Now we know the I, we know the V, we know the cos phi. We can calculate motor input power. We already know the motor net output power, that is 7460. So 7460 divided by VI cos phi will be your answer.
Okay.
I'll just show you the solution. You will be more comfortable. So this was your question. Okay. So just understand these few things first. Power input phase in motor, phase in stator. Power equal to VI cos phi. I is armature current. Armature copper losses are equal to I square RA. That is IA square RA, armature losses. Mechanical power of in armature is PM equal to EB cos phi. And there are iron and excitation friction losses, and one side there is output power. So these are the cycle. AC electrical power input to the stator, that power is known as power in. There will be some copper losses. There will be gross mechanical power developed. This power is known as PM. There will be excitation losses, iron losses, and then net mechanical power output that you are getting at your shaft. Understood this much?
Yes, sir.
So what we wrote? We wrote motor input equal to VI
VI
cos
phi.
Okay, armature losses, we already said I square R. Here it's written incorrect. Just you write it correct. Okay. Power developed in a armature will be equal to PM will be equal to VI cos phi minus
losses.
losses. So we can IA will be equal to,
This one.
we have only changed the equation, right? We brought everything to this side and it will become equal to 0, right?
Okay.
आप आई स्क्वायर आर इधर है, इसको इधर ले आओगे, ये प्लस का हो जाएगा, ये प्लस हो गया, वी आई कोस
हाँ
फाइव माइनस है, प्लस है,
वो
इधर
कर
आके माइनस हो गया, ठीक है, इतना तो कर ही लोगे
वो तो कर लूंगा मैं निकाल
ना।
लूंगा, ठीक है समझ गया। सर वो
पावर
मुझे
आउट।
थोड़ा ना कंफ्यूजन होता है कभी कभी, जैसे पावर नॉर्मली वीआई लेते हैं ना, कहीं कहीं वीआई कॉस फाई किस किस में लेते हैं, फिर कभी कभी जैसे इसमें अभी इनपुट लेना था तो इनपुट वीआई कॉस फाई थी, और मैं सोच रहा था ना कि पूरा ही पावर ही वीआई कॉस फाई से हो जाना चाहिए था, लेकिन मैं टावर डेवलप ले रहा था, आर्मेचर में वीआई कॉस फाई ले रहा
Okay, so power output is 7.46, so 74760. Power,
था।
gross mechanical power is equal to power output plus this losses
फ्रिक्शन लॉस। हाँ
and excitation loss. So this is already given in the numerical. It comes out to be 8760. Now this was the equation for current. We know the V, we know the cos phi given, V is also given, cos phi is given, RA is given, PM we already calculated, 2RA we know, right? So we are going to get the value of I. So value of I will be this. You calculate again what is the value of IA, because here by mistake they put the 3760 instead of 8760. Okay. So as per their calculation, it's coming up. But I think they put the wrong, but still they calculated it right, because you are going to multiply this 4 with the 3, it's coming 12,000. They have written 28,000. I think their calculation are right. By mistake, this is the printing error. So it comes out to be 20.2 amp. So motor input again, VI cos phi. We know the I, we know the cos phi, we know the voltage. So it comes to be 9090. Efficiency always output upon input. So it comes out to be 82.06. But you have to do the numerical by your hand, then only you will be able to solve in the examination. Okay, then we will go to the next question. Next question which you posted in group is this one. A diode. A diode, right?
Internal resistance is 20.
So I think you can solve this question, but you don't know the few formula. That is the only problem. A diode whose internal resistance is 20 ohm is to supply the power to 1000 ohm load from 1110 V RMS source. Calculate the peak load current, DC voltage, AC load. So what will be the VRMS is given? What will the maximum value of voltage?
√2 VRMS.
Multiply by √2.
Yeah.
So what value of voltage you are getting?
155.56.
Very good. So all of us know V equal to IR. So I is equal to V upon R. So we know the total resistance. What is the total resistance?
120.
1020.
1020, sorry.
1020. We already calculate the voltage. Can you calculate the current?
0.1525.
So what is the problem? You already did the numerical, no?
नहीं सर, नीचे वो है ना सर, IAC या IRMS, IDC.
So DC load current will be, DC load current formula is peak load current divided by pi. Okay, this is the formula for calculating the DC load current. And for calculating AC load current, the formula is for calculating AC load current, peak
AC
load current
हाँ,
divided by 2. Okay. Since you already know everything, this is very good. I'll just show you the solution. We will not
नहीं
waste
बट
much time.
ठीक है। तो
Let's see,
ठीक है,
any doubt? This up to here you already solved, right?
हाँ,
Because you don't know these two formula, that is the only problem.
okay,
Clear?
no problem, ठीक है।
Okay, sir. That was planned from my side for today. You want to ask anything, you can ask.
No sir,
Okay. Then I think tomorrow we will keep it off. We already discussed the problem you put in the group. So tomorrow we will keep it off.
ठीक है,
Okay. Any is good. You are solving question and you are putting in the group. Oh, Vignesh is also joined. I don't know when he joined. Vignesh,
I joined after 7 minutes, sir.
you came just now.
No, sir. I joined after 7 minutes, sir. Just one late.
So you were there in the auto transformer also.
Yes, sir. Yes, sir. We
Okay.
started in the Star Delta. Star
Ah,
Delta.
okay. I don't know. Somehow the notification sound didn't came. Okay.
उसको भी
I'm
नहीं
really
दिखा।
sorry. I didn't notice you.
Okay.
So I hope it is clear to both of you.
जी
All
सर,
the question which you put in the group and star delta, auto transformer, DOL.
चलो,
Auto
Yes, sir.
transformer is little bit tricky. You have to study maybe 1 or 2 times. Then it will be okay for you.
ठीक है,
Okay, sir.
Okay. So we have already covered a paper of July, right? All the written question, all the numerical,
yes sir,
right? Okay.
Okay.
Okay, guys, then that's all for today. See you on the Monday.
okay.
It's better if you put some question because if
I
I
I will put शाम तक डालता हूँ अभी तो आटू
because
बनाओ।
that give me some also motivation to look for the things. Otherwise, I feel like whatever I'm doing is okay, right? The more you are going to push me, it is going to be better for you as well as for me also, right?
Yes, sir.
Okay. Okay, guys, thank you for your time.
Thank you, sir.
Okay.